Okay, everyone, so we're going to go over something known as scientific notation. A lot of the times when we're dealing with numbers in science, you can be dealing with very, very large numbers or very, very small numbers. Okay, so for example, the mass of the moon, right? It's not going to be a small number. It's not going to be like 100 grams. Or something that's very, very small, such as the mass of an electron. Right? Very, very, very small quantity. So we have a different way of expressing our numbers in a way known as scientific notation. Now, you've probably seen this in grade 9 or grade 10, but we're going to go over it this time. And it's going to be taught as if you've never seen this before, so don't worry, okay? So like I mentioned, science, right? We have a lot of large numbers and we're dealing with a lot of small numbers, right? So when you're putting something like this, let's say into a calculator, right, this is going to be, first of all, very difficult to keep track of how many numbers you're putting in, right? So let's say you have like 19 zeros, for example. Maybe you get distracted around zero number 10, or somebody calls you, or your attention is diverted. It's very easy to make an error. And the other thing to keep in mind is that most likely your calculator won't even go to this many digits, right? So if you just were to, let's say, start typing out a bunch of zeros in your calculator, it most likely will give you an error because there's only a certain number that it can hold within its memory. So there's a much easier way to work with numbers like this, and that's to put it in a scientific notation format. Right, so imagine you had to do the multiplication of these two numbers, right? It'd be almost close to impossible, right? So here's our scientific notation format. So it's essentially, when do we use this? It's a method of representing small or large numbers. So the format is always the same. It's M, okay, and M is a number between 1 and 10. And then we have, so let's say, I'll give you an example with an actual number. So let's say we did 2 times 10. So there's always the times 10 portion. And on the 10, there will be an exponent. So the exponent is always a whole number integer. So it can be a positive number or it can be a negative number. And we'll look to see when we use that. I'll give you an example. Let's say we have times to the 10 to the negative 2. So this number will change because it will depend on what you're doing. And the exponent number will change. But the format of this is always the same. You have some number between 1 and 10 times 10 and an exponent that is a whole number integer. And again, that can be a positive or negative number. So we're going to look at, well, how do we get that format down? So let's start with an example of something that is very, very big. So here we have 2,500,000,000 is our number. And the goal here is we want to put this in the scientific notation format. So first of all, if there is no decimal point in your number, you're going to put a decimal point in. All right, so as you learned probably in elementary school, ooh, my decimal's not looking so great. Okay, there's my decimal. So as you learned in elementary school, if you have a number with no decimal in it, the decimal is always behind the very last digit. So here's our decimal point. Now, the goal of this is we want to move the decimal point so it will give us a value between 1 and 10. So remember, the setup of this is we always want a value for the number to be between 1 and 10. So for example, let's say I were to move it here. This number is still, like imagine this has now shifted all the way over here. So this number is still 2,500,000. That's definitely not between 1 and 10. If we were to move it, let's say here, right, so we were to keep moving, we're going to move the decimal, and we moved it here. Now the number I'm going to get is 25. That's still not between 1 and 10. And if we were to keep going, right, let's say I were to move it here, this would now give us 0.25, right? So it's actually, we've moved it too far. we now have a number that is less than 1. So the key is we need a number that is between 1 and 10. Okay, so a nice way to remember that is we want to move the decimal behind the very first number that's not a 0. Okay, so by moving it right here in this spot, that now gives us a value of 2.5, which is perfect. That's between 1 and 10. So what that means is now our base value is 2.5. That's what we've shrunk this. We basically condensed this number down from 2,500,000,000 to 2.5 times 10. Now the exponent, remember the format always has the number between 1 and 10 times 10 and then an exponent. The exponent is actually going to indicate how many times was the decimal point moved. So in this case, you would literally just count it out. So we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So our exponent here is going to be a 9. So we went from this really big number to a reasonable number that we can actually put into our calculators for later on. We're going to do some example calculations. I'll show you what we mean by that. So the exponent tells us how many times have we moved that decimal point. Okay, now if you remember, I did mention that the decimal point could be a positive or negative number. Okay, so let's take a look at what happens there. So here we have a small value. So before we were dealing with a very big number, here we're dealing with a very small number. We want to put it in scientific notation still. So remember that means we want a number between 1 and 10. So here we have 0.0000579. So if we were to move our decimal point here, this would be 0.579. If we move it here, this would be 5.79. This would be 57.9. So the sweet spot for the decimal is actually behind the number 5 because this will give us 5.79. Now we want to see how many times we move the decimal point over to get that. So we have 5.79, and remember it's always the times 10 format. And we have now to count how many times was the decimal moved over. So we have 1, 2, 3, 4, 5. So we've moved it 5 times. Now here is the difference. Because we moved the decimal point to the right, we've made a small number into a scientific notation. That is when we add in the negative exponent. So meaning, let's go back for a second. The positive 9 means that we moved the decimal to the left 9 times. The negative tells us we're moving it to the right. The number itself still tells us how many times we're moving it, but the symbol will basically tell us, was it a large number to start or was it a small number to start? So here we would have 5.79 times 10 to the negative 5. So the exponent is negative because the number we started with was less than 1. So it was a small number to start with. Okay, so before we start looking at calculations, I'm going to give you some to try on your own. So for all of these, the goal is we want to convert into scientific notation. Okay, and I'm going to give you some to try. So let's do... Okay. 2. Yeah, that's number 2. Let me see if I can squeeze in maybe 5 to do. Okay, so pause the video. I want you to take each of these numbers, there are 5 examples for you to try out, and I want you to put them into scientific notation format. So remember, that's always going to be a number times 10 to some exponent. Okay, so give that a try, and we'll take these up. Okay, so hopefully you gave this a shot. So let's take this up. We'll do our answers in blue here. All right, so here we have 70,000. So this would convert into 7 times 10 to the 1, 2, 3, 4. Okay, so right now, my 4 is not looking great. So right now, this is acceptable. You may have also written it as 7.0 times 10 to the 4. That is also acceptable. So later on, we're going to learn about a topic called significant digits. Once we learn that, that will help you to decide which one you would write down. For now, the goal is to just practice putting it into that format. Number 2, we have 0.0081. So this should then be 8.1 times 10 to the 1, 2, 3. So this is going to be, it should be a negative 3 because we're moving it to the right instead of to the left. So 1, 2, 3, 8.1 times 10 to the negative 3. Here we have quite a large number. So we have 5.2 times 10 to the, right? So there's no decimal here, so you assume it's at the end. 1, 2, 3, 4, 5, 6, 7, 8. So this should be 5.2 times 10 to the 8. Here we have 0.00011. So this becomes 1.1 times 10 to the 1, 2, 3, 4. This should be a negative 4 in that case. And number 5 might have been a little bit tricky because it's already a number between 1 and 10. But if you're asked to put something into the scientific notation format, you still have to follow the proper format. So what that would look like here is 8.2 times 10. And actually, the exponent in this case would be a 0. Because what happened here is that we did not have to move the decimal point. So you're still putting it into scientific notation format, but because we're not moving the decimal point, we're just going to put a 0. Okay, so the next part of this video is we're going to look at how to now use these scientific notation numbers into our calculations. So you might want to have a calculator handy.